everyone. I will make the opening and introduction. Distinguished participants, we are here in the 5th day of Zero Build Turkey with the session number 55. I will be the moderator of this session. I am Züleyha Özcan. I'm a mechanical engineer and I am at the TurkeyMÜKAD Association of Women Engineers and Architects. I'm the president. And in the 5th day of Zero Build Turkey, we listen to many prominent speakers. It's been a full-packed program, and we have very prominent speakers here in this session, and they will enlighten us. If you wish, I'll give you information about the speakers and their subjects. Then I'll give the floor to our guests. The first speaker will be Mustafa Türkmen will be our first speaker. And he's going to talk about PresidentModerator Technology General Manager, the importance of LED lighting technologies to zero building. And then Abdullah Yaman, CoordinatorConsiderations Kitchener R&D coordinator, will talk about considerations regarding the selection of energy efficient electrical appliances. The third speaker is TurkeyWarmhaus Managing the Director. He is going to talk about the importance of heating sector in zero energy field. Our last speaker is from AcademicianEnergy University Mechanical Engineering Department Academician Head of Department, Professor Dr. Brahim Atmaca. He's going to talk about energy efficient systems in industrial building, air conditioning. So I'll give the floor to Mustafa Türkmen, and I'll give you information about his background, and I'll leave the floor to him. Associate Professor Mustafa Türkmen, he is an academician in RGS University Department of Electricity, and he had his PhD and master's degree in the Department of Electrical Engineering in 2003 and 2009 respectively. Between 2009 and 2012 in Boston University, he acted as a visiting lecturer, and he's researching nanotechnology, better materials, plasmatics, and their chemical applications, lighting technologies, and antennas. Mustafa Türkmen, between 2014 to 2019, he acted as the representative of the TR22 region, and he had his activities with the industrial organizations and academia. And he is also he's the founder of Photonic Technology Incorporation. Mustafa Türkmen, now I'd like to give the floor to you. You have 15 minutes. Thank you very much. Thank you very much, distinguished participants. I'd like to pay my respects to you. I'll share my screen right now. You can see my presentation, right? Yes, we can see it. Today, I'll talk about LED technology and its place in the energy efficiency. Thank you. Today, I'll talk about LED technology and its place in the energy efficiency and its importance in energy efficiency. We have established photonic technology and in 2012, and we are working on the photonic systems and high technology systems, and of course we are working on human-focused lighting systems and also greenhouse systems, and we have a CE mark the products. the lightning started with 4 million years ago, and in 5,000 years ago, it started with the fire. In 1936, with the fluorescent technology, there is a new technology, and of course here in this is still a light sources spectrum, and we see in incandescent there is a blue light is low, and it's about more, and in fluorescent bulbs there are different wave lengths, and this is harmful for the human beings. And there is the halogen bulbs. Then in 1996 there's a LED system, and there is a new LED technologies are started to be used in today. And in LED systems, in the first discovered LED, as you can see, blue light is very much, as you can see in the upcoming years, and this causes the eye disorders, eye-related disorders. However, then in 2000s, with the activities, the LED technology, the development of LED technology, there is a lighting there, and of course, with the blue light, the wavelengths are used for the lesser with less energy, and there is more sunlight or and sunlight lights and LED systems have been developed, and the lighting technology in 2020 will be 61% will be LED. And when we look at the 2010 and 2020 data, and we believe that this figure will be more than 61%. And as you can see, with the LED armatures and installations, there are LED light bulbs, and there are other fluorescent light bulbs in halogenous ones, and the implemental light bulbs, they are mostly in use, and in 2035 most of them will be LED armatures and LED lights. We can see the lumen per watt values increase, and it is 1.4, and it sorry, Mustafa Bey. And if you can stop your video, sorry for that. Is it better now? How is it now? This is better. Thank you, Mustafa Bey. Sorry for that, and I'll continue if you allow me. The LED costs are decreasing vastly, and human per watt values based on the energy, the light value increases. And in 2020, of course, it is expected that it will be even more. And the metal halide and the fluorescent light bulbs are used, and in many of the buildings, there is still fluorescence used. And in our country and in the world, the fluorescent lamps and metal halide lamps are changed with the LED armatures. And actually, this is not a very high cost process. As you can see, it is the metal halide is a 15,000 per hour. So in 7 and 8 months, the armatures have to be changed. However, in fluorescent, it is a 25,000 per hour. However, in LED armatures, it is 80,000 and 100,000 values. And when we look at here, we see the same, the halogen ones, metal halide and fluorescence, and also the high pressure sodium or copper, high pressure copper lamps, and also the instead of these armatures, there are more the LED armatures, and also we see the armatures are better. And if you're going to use 100 watt energy, you can take 1,300 ones, and in halogens it is a 70 watts. It is there is a 1,300 lumen. However, in LED it is at 18 watts. So in return of 16 watt of energy consumption, you can get a 1,300 lumen light. Of course, for a LED, there needs to be the LED modules to be developed for the LED armatures. So there are the lenses there, and then with the driver circuits, the energy is provided, and with the aluminum boxes, there is the dust and water impermeabilities conducted, and the LED armatures are prevented. And of course, we see the whether this is, of course, it depends on the area, type of area, whether it's a production area and manufacturing area, and how with the armatures that we place, how many watts should they have. Of course, there are the dialog blocks, softwares with the package programs. We made the analysis, and there are solid modeling and also electricity circuit design. So with the package programs, we made the design first, and following that, we continue with the manufacturing. When the LED modules are manufactured, the assembly lines are used. This is a full automatized line. It is within our company. So there is the printing and circuit cards, and there is a cream points, and with the 3 so with up to 18 micrometers, there is the analysis is made with the solders, and the controls are made, and then following that, the integration of transistors and with the printing machine, they are placed on the LED, and following that, with the nitrogen cooling, with the 10 with the 2 zones cooling, with the 7 zones heating. This is the LED modules are prepared, and with the 3D optical readers, there is with the solder is conducted with 165 degrees, and with the 3D evaluation devices, so we check whether there's any degeneration or not. And this is how the LED modules are manufactured. And the LED modules, as you can see, we have the production line, assembly line, and in special foundation. And with gonio-photometer, we looked at this, the lumen per watt and the efficiency values, the heated light values, or how many fluxes, how many kelvins lights, and they're all made analysis with the laboratory devices. And also these products are put into the cases, and there are cooling cases, and there is polycarbon or PMMA shield and diffuser are placed, and the net drivers are placed, and the LED armatures are manufactured. And in order to have energy efficient buildings, of course, we have to use the LED armatures. And in every part of our life, from health to education, the LED lighting technologies are in use. As you can see, this is when we give a 6,500 Kelvin of light, it is a more white, and it is below 2000. It's more yellow light with a halogen and filament halide. We have the light temperature similar to that. And in healthcare and in the antibacterial light applications, the light technologies are used with the ultraviolet systems. And when the pandemic started, when the coronavirus, the pandemic started first, there is ultraviolet CE disinfection systems were put into use, and in household use, the lightings for 6,500 is used. However, in the bedrooms, it is 2,700 and 3,000 Kelvin is used. And of course, when we look at the human-centric lighting, we see that these values should be changed as it should be suggested and proposed. And in these studies in the Europe, in order to have the buildings, in order to have zero energy buildings, so the LED technologies and LED armatures use is recommended, and at the same time, and of course, the LEDs are changing the color during the day is also put into use. And in the greenhouse lighting and automation in the vertical agriculture, the LED armatures are prepared, and in our company, Mustafa Bey, can you hear us? Can you hear us? I thought that you dropped from this. I can hear you right now. We have few minutes. I'd like to remind you of this. Please continue. So I will finish very fast. As you can see, in the multi-story greenhouses, these are applications which are more common in Europe. In the there was the red and purple light mixture was used. However, with the technology, it is used the technologies. There is some light like systems are used with the human-centric lighting, and with the lighting for the vertical agriculture we are used. Also, Philips Zumtobel and LED products are used, and we can say that for this products now account for over 40% of total revenues compared thinking of all of these brands. And thank you very much for your understanding and for your patience. Thank you very much for this very nice presentation. While I was listening to you, we received some questions. I have some notes as well. So when we say LED technologies, what is the place of them in energy efficiency? And is it too costly for turning the current lighting to LEDs? With the dialux analysis, lux analysis, we make analysis of this, and we make the design of lighting, and also we receive a ROI, I mean return of investment cost, and the return of investment cost in metal and halogen lamps. It is 1.5 years. So this is the return of investment of costs. So it has such a high energy efficiency. So with 18 watts of energy, in 1.5 2 years, there is the return of investment and LED costs are dropping very fast. And for the new technologies, with the new generation, there are some innovations. How is the sector is going? What is the direction of the sector that is proceeding? As I pointed out in my presentation, especially in the studies in Europe, the headache, especially in the environments when there's fluorescent use, and in even our customers, we see that people are disturbed. They don't want to see the light because they have headache. There are such complaints. So from now on, especially in the elderly care houses, there will be human-centered lighting systems in use. And within these systems, as I pointed out, the white there's a light wash system with the white color, and with there's a 6,700 Kelvin is provided, and with the metric values, then it is becoming like a sun daylight light, and it decreases to 2,700 Kelvins, and after 9 in the evening, so there is a very dim light is proposed to be used, and in LED systems with automation systems, of course, based on the season and based on the hour of the day, there is this automatized systems are in use in many buildings. I don't want to give, for example, I don't want to make commercial, but at the end of 2018, a huge hotel chain, they said that we host people with the human-centric lighting systems. They make such advertisements. And as of 2025, in most of the hospitals and schools and in different systems, the LED armatures will be used. So this is what we foresee. In your presentation, the human-centric lighting issue actually attracted my attention based on different hours of the day. There are different lightings, and of course, this is something new. There are very good research, and I see that regarding the technologies of future, we are working on this, and of course, with the automation, after the white light, if there is circulatory systems, I don't know when this will happen, but I'd like to ask you. So about the future, the technological activities, what are you doing and when will we achieve this point? Actually, there are many companies researching about this. For the prominent companies of Turkey are working on this, and in the few years, the systems will be even more disseminated. And we have a huge manufacturing company with a huge dealer network. Last year, they wanted us to make an installation, especially in the administrative building. They wanted us to make a study about the human resource, human-centric application. Professor Dr. Züleyha from Bolu University, with different companies working in regard of human-centric effects of human-centric lighting on the pregnant women, and we also have some joint projects with him. For example, this is made in a very different part of Europe, and of course there will be automatized systems will be in our lives. That is what we foresee for the future. Thank you very much. I think that the awareness should be raised more and more, and people have to be aware of this. Thank you very much for your presentation. Now I'd like to invite the second speaker. Thank you very much for the information that you provided. If you allow me, I'd like to continue with the second speaker, Abdullah Yaman, Korkmaz Kitchener R&D coordinator, is going to give information about considerations regarding the selection of energy efficient electrical appliances. I'd like to give him his CV. He was born in 1965 in Çorum. Between 1991 and 2008, he worked in the he worked as a manager in the food and electronics sectors, and since 2008 he's been working in the R&D projects. In 2008, he established the regional this branch of the Kitchener, and since 2013, he is working as R&D and also consultant to board of directors. Abdullah Yaman, he completed 18 the ministry executed 18 projects, and in 24 projects he acted as a consultant, and he had these projects, and with their team is working in this regard. And he's a father of, he's married with one child. So I'd like to give the floor to you. You have 15 minutes. Thank you. Abdullah Bey, you can unmute yourself. Thank you very much, but I have a problem sharing my presentation if our friends can help me. I think that the technical team will assist you, Abdullah Bey. They've taken their notes. Thank you very much. The energies that we use at our house, we use except for heating and cooling, we use electrical appliances and lighting. As Professor Turan, the Türkmen talked about the lighting, and I'll talk about electrical appliances. As you know, that the building stock is more than 17 million, and in the residential areas and in the offices, in order to increase the comfort and facilitate the life of people, we use the home appliances. For example, in the offices, there are refrigerators, ovens, and coffee machines, and we have such appliances, and these are the indispensable part of our lives. And while using these devices for making a coffee, so we don't think the share of energy cost, because we can say that the energy for making coffee is lower than the energy that we spend throughout the day. However, this is right in a sense. However, when we multiply it with the 18, we can see the cost of coffee for our country. Is there a problem with my presentation? Let's continue.
I think our technical team is working, and the team will share it now. Yes. We have wide appliances, and the concept of energy efficiency has become more dominant and has gained more space without losing the performance or without losing any performance. They accept for example, refrigerators, fridges. As known, heat moves towards the cold area. So in order to transfer the heat from cold to hot area, then we need to work, and we need to consume more energy. Therefore, according to the research that has been done, 30% of the electricity is consumed by fridges. Today, we have this energy performance etiquette. It shows A, B, D, and G, and if it is A, it is 23% less than B, and it is 45% than D, and 56% less than the G class. Energy certificate is important for the fridge, and these type of energy efficient fridges consume half of the energy that was manufactured before 1993, and it is equal to lightning cost of 4 fridges. And this efficiency is important for equipment and white appliances. That means it is equal to the energy consumption and also energy generation of power plants. We have 3 million fridges. That means about 540,000 kilowatt hour, and it is equal to the 5 power plants, thermal power plant. Of course, it is same for the washing dishes, laundry, Professor Dr. Muhsin Kılıç is drying machine, and also dishwashers. And a dishwasher, if it is with energy efficiency certificate, then it consumes less energy. And if it is A class, then it can save 32% according to the comparing to the class D, and 48% comparing to the class G. So it is important for the electricity consumption. Choosing the energy efficiency is important. Television and computers is the 4th category. The televisions that are available in the market, and 71% of these televisions has class A, and the rest is in lower classes. And we know that 82% verification and validation of these numbers, which is acceptable. Of course, television is used very commonly, and it's used very often. In fact, it is the 2nd most used white appliance after the fridge. And if you have A class energy efficiency, then you save energy. If you have a LED TV, it is 80 megawatt, and we need about 15 kilowatt per hour per month. That is 3.2 billion kilowatt per hour. That means we need 360 megawatt energy. And we have stoves, almost all houses, and these stoves consume about 2-3 kilowatt per hour. Of course, it changes according to the temperature at home. A family with 4 members, a nucleus family, if we consume that they use it for 1.5 hours, then it is 30 kilowatt hour, and in total it becomes 1 billion kilowatt hour across the country at the country level. And even if there is an energy consumption or an energy efficiency, 1% energy efficiency, that means 10 million kilowatt hour saving. And the power plant in Bursa has 1,400 megawatts, and it costs 512 million US dollars. That means these type of small steps or small actions can save a lot, and we need to make investment to compensate this loss. Another interesting point is this toast machines, because if you use this toasters, you can use this and it consumes, if you use it for 1 hour, it consumes 1 kilowatt hour, 1 kilowatt per hour. But given the fact that it is not used so often, it is still important to have high-tech toasters to save energy because it consumes a lot. And the last one is the kettles. Turkey is one of the countries that consumes the highest amount of tea. And it is another important category that we should take into consideration, because tea is consumed not only at homes, but also in all workplaces at all scales. And so making tea may not seem something so expensive, but it costs a lot because we have millions of houses and workplaces that make tea every day. It means that we consume energy. So if we, for example, consume electricity for 2 hours, that means 0.75 kilowatt per hour. And if we multiply it by 34 million houses and workplaces, it gives you an idea about the amount that we consume energy. In this respect, manufacturers are doing their best to produce it efficiently. That's all from my side. That is the end of my presentation. Thanks a lot. Thank you, Abdullah Bey, for this presentation, for sharing these important tips with us, because these white appliances and the equipments at home are very important. I wonder, for example, the stove. You know, this natural gas, we use it very commonly, and this stove with induction, with electricity, given the fact that electricity is generated in natural gas power plants. So which one we should prefer? The stove with electricity or natural gas? Which one you suggest? First, it sounds natural gas, but natural gas, about 20 to 25% is used for cooking. So electricity is more advantageous, especially in the new system. This stove with induction is much more advantageous. We have seen this type of practices because when we look at the consumption of electricity, I'm talking about the stove only. Of course, heating for heating to cook the food, it is microwaves, but thanks for your point. And also these kettles, you said that manufacturers are working on new technology. It is important for us. So can you kindly inform us about the issue? Do we have high tech? Can you kindly elaborate this part, the kettle part? In these type of products, usually there is a mechanical thermostat that is the basis of the operation. And these thermostats have a system. It stops according to the limit that you set in the beginning. For example, it is different according to temperature at home or in the environment that it works. So if you use the same product, in the south and in the east, it is different. But since the limits are same across the country, it is not so efficient. And our company is working on a new system to have a dynamic thermostat. So it can easily calculate and consider its temperature. And then we have a new software that calculates temperature and then stops working according to the optimum need. And compared to other products, we are testing this and it saves about 30% energy. It is too much. It is a considerable amount. Yes, 30% is a considerable difference. Thanks a lot. The second question is as follows. You are an assembly member of the TOBB about these appliances. What kind of activities do you have there in that assembly? Of course, TOBB is the key institution and organization for our part, and I'm a member of the sector assembly, and I'm representing my organization there, my company there, and we are working on several issues, including the developments in different parts of the world. We try to learn what is happening there. We issue energy performance certificate and documents, and also we have a legislative committee that facilitates the process, the legislative process before the national authorities, and also we act as a mediator between the public authorities and the manufacturers. Thanks a lot. Now I would like to move to Mr. Turan. Before I give floor to him, let me introduce him first. Turan was born in Sivas in 1975. He studied mechanical engineering at Yıldız Teknik University, and he completed MBA at Koç University, and he began working for Wayland in 2002, and then he began working as sales manager in Immer Gas, and from 2007 to 2010, he served as the general director of the company, and he's still working as the brand company of the TurkeyWarmhaus, and he's working in the energy efficiency, and he is working on digital transformation department. Turan is married and has a son, and he will talk about the importance of heating sector in zero energy field. Please unmute yourself. Hello, everyone. Thanks for your kind introduction. I watched my life story while you were introducing myself. Thanks a lot. Can you see my screen now? Yes, we can see it. It is the heating sector and its importance in the zero energy field. Now yes, now it works. I don't want to focus on figures mainly. Rather, I wanted to share some points that the customers are interested in, but just one figure, 47.7 billion cubic meter consumption, this natural gas consumption. And there are three main sectors. It is mainly individual houses, industrial consumption, and power plant consumption. And as for the individual houses, it is 15.4 billion. As regards to industrial consumption, it is 12.7 billion. And as for the power plant, it is 13.6 billion. And we as the managers, we do our best to reduce the consumption. We work with 4.0 and we make detailed calculations about the consumption of these machines and these devices. We have all these issues and we have units that are working on this issue so as to minimize the consumption, so as to achieve the efficiency. However, as regards to consumption of the individual houses, the level of awareness is different. And if we calculate the consumption and if we calculate their level of awareness, we will realize the way that we need to take, the way that we think about. Therefore, I will focus on the consumers. Of course, there is a lot to say that affect zero energy. And I think focusing on consumers aspect is quite relevant. So the question is, how smart heating system that we use? So it is about the heating attitude that we have. When we look at the last decade, it is the pandemic and also energy efficiency and some other problems, because these type of issues that go beyond the social responsibility projects only, because we have some other aspects. So it has become an issue for all individuals. And in order to use energy, there are several equipments. And the first one is the digitalization. Digitalization is a key tool to achieve these smart heating systems, because since digitalization has dominated our life, we have smart watches and smart phones, we have smart cars, but we need to change the system and the appliances that we have at home, and we need to make them smart. That is the first question that we should ask. And while we carry out the market research, as you see, consumers pay attention to saving much more than any other points. And since saving is very important for them, in our marketing survey, we ask the question whether they know the concept or not. And this condensation, which is very important for the saving, because manufacturers make some innovations and they can save energy, and we supply these appliances to consumers. For example, Abdullah Bey just mentioned a kettle which calculates temperature automatically and then arranges itself, adjusts itself according to the climate. So we as manufacturers do our best. Yes, our productions are smart and people have expectations about savings. But what about our habit, our attitude? I will talk about a product that we have, that we supply, and when we look at data of our customers, we see that they do not use the features of our product as they should, or as they can, let me say, for cooling purposes, for heating purposes, or for hot water, because they use the appliance in a smaller capacity because of their behaviors, because of their attitude, since they do not have required conscious and they do not raise their awareness. For example, what about hot water or for the combi part? Yes, we have this digital tools enable us to achieve efficiency. We have this LED lightning, and Murat Bey talked about a similar issue. And consumers can use these type of devices that take us to productivity and the efficiency. For example, we can use Wi-Fi, and we can control the device in any place that we are, and we can customize it. We can achieve savings. Of course, you can match it with our devices, which are with our products or some other products. So you can use the remote control thermostats, and you can arrange the level of temperature. For example, what we do, for example, if there's a room that we do not use, we just turn on the valve and then we save it. But if you turn it off, then you do not save. That is the traditional way. So these type of devices save energy and also achieves efficiency. We have different modes like the economic mode, etc. And when you are not home, you can still turn it on or turn it off, and you can control the heating needs and also the systems. What does it mean? So our homes are getting smarter. There are always new products that work on the basis of digitalization. So the issue is, are we aware of them? Do we use them efficiently? That is the point. So we need to change the habits, the attitudes towards this. And I'm talking about efficient use of these devices, these products and appliances, so that we can shorten the journey to zero energy. And if our consumers, our customers are aware of the devices, then we can save a lot. And we can save 2.5 billion US dollars. And it is an important contribution to the country. And it's an important contribution to the financial situation in our country, which cannot be ignored. Thanks a lot, Mr. Turan, for your presentation, especially raising the point of awareness among consumers. Yes, there are systems that we design in a smart way, but if we do not use them in a smart way, usually it is on and off system and we consume energy. And of course, it is not easy to explain because people pay money And if you spend money, then you are sensitive. But when we do not raise awareness about this issue, it is more problematic. We need to work harder. It is one of the key issues. So it is not the only issue, of course, but we need to have this automation system which is not actively used. Hope that we will be able to change it. I would like to add one point here. So we are talking about electricity, but the key issue is related to insulation, because most probably my colleague Özgür Alioğlu talked about this issue because he works very hard on this. Years ago, I remember that while I was working as an engineer for Wyland, and the construction was not completed, but the owner of the house bought a combi for the house. So it was not efficient for the owner of the house. I think civil society organizations are important to raise awareness because companies are working very hard. We are all working very hard, and these efforts cannot be ignored. We work with professors, we work with universities. These are important studies. But sometimes consumers are not aware of the functions of these products. We teach the functions of these products to our branches, because we can make contributions to the economy. It's a very important point, because it is important while you are selling it. And for us, saving is that if you turn your combi off while you are not using in one room, then it is the saving. But that's not the case, because there are some other steps to be taken. We need to improve it, and there is need for a training. My question is as follows. As regards to the end users, is there any incentive to buy these high-tech products? Of course, I can say there is no incentive, but the question is it enough? For example, I don't want to give an example from Europe, but last week, I visited 2 countries, and what I experienced is that they showed me a new building with zero energy, and I informed them that I will talk about this panel, and then he said, you can refer to my house. There is photovoltaic. In his house, there is solar energy, there is heat pump, and he said the house was fully supported by the house. And in fact, the amount of the support, the incentive was 115%. And Germany is not an exception. Germany is providing incentives as well. My point is, such incentives are important to raise awareness among consumers. But if we are talking about the root consciousness or raising awareness at the root, it is important to pay attention to kids at schools, etc. I fully agree with you. As you said in the beginning of your presentation, heating and also drying are key categories that we need to follow. So do you have any specific activity, or what is your objective to achieve these technological developments? We are working on developing new products. But while we are working on new innovative products, we follow the trend at the global level, and we are working on heat pumps, for example. These are important goals for us. It's an important objective for us, but in the short run, we work on this remote control, which is an important product, and we aim to promote it so that people can change their habits. We work on new products. Our research and development unit is working on new products every day. So rather than a new product, we are working on the concept of digitalization, which is very important for changing the habits. Thanks a lot, and wish you success in your activities. Now I would like to move to the last panelist, to Professor Dr. Ibrahim Atmaca.
Mr. Atmaca was born in Antalya in 1969. In 1999, he went to Uludağ University, having undergraduate in mechanical engineering, and in 2001 went to Uludağ University from mechanical engineering with a master's degree. Also, he earned his doctoral degree there, a PhD degree there, and he studied. He was assigned as an associate professor to Akdeniz University, and he became a professor in 2002. He will be talking about solar energy supported absorption systems and also thermal control, and also different applications of nano applications and energy efficiency in buildings. And also he has other studies in the relevant areas. He is currently is mechanical engineer. He is the chair of the mechanical engineering department at Akdeniz University. He is married with one child. And now he's going to talk about energy efficient systems in industrial building air conditioning. The floor is yours now, Professor. Thank you very much. We listen to different approaches about zero energy buildings and active system solutions. Now I will be talking about places like offices, faculties, or resorts. I mean, more commercial buildings. And here, heating, ventilation, cooling, fire, all other elements will be included in my presentation in terms of energy efficient solutions. As for the contents of my presentation, smart buildings and HVAC automation, heat recovery, heat pumping. Also, together with the pandemic, I want to talk about the importance of heating and cooling in the Mediterranean climate, and which integrates air. This will be heat pumps. Also, regeneration practices about what we can do in the buildings, and indirect use of evaporative cooling. And the future is coming. We're going to give up on water, air, and even talk about nano flow systems. Actually, shortly, we know that primary energy is accounted by the industrial buildings with a 32%. However, together with commercial and other service buildings and residents, we spent as much time, as much energy as the industrial area. That applies to final energy consumption as well. The industry accounts for 47%, and residents and commercial buildings actually account for an equal amount. That's why we had an energy efficiency law. And here we have BEP, building energy performance regulation published as a result of it. It's a beautiful regulation with its scope. Unfortunately, we got stuck somewhere, which is the energy identity document. There was this period provided as a deadline. It showed actually just a deadline, and there were other elements, and it said industrial areas with a size of more than 20,000 square meters should have renewable energy sources, air, soil, and water energy, heat pumps, cogeneration, and microgeneration. And also, it said that they should account for 10% of the total costs of the building in the regulation. And my speech will actually refer to these elements. As we move towards zero energy buildings, we value automation systems, but we cannot make each and every building a smart building because in addition to having passive energy efficiency, we need automation systems, and that would mean, of course, high first investments. But in public buildings and office buildings where we have high number of users, we can actually have to use these smart automation systems. Here we can first refer to passive systems, energy effective passive systems, but with the architectural planning, their orientation, their air ventilation, and just as our colleague mentioned, insulation become all the more important. But heating, cooling, and ventilation automation can provide us an efficiency level of 35%. In other words, savings equal to that amount, and we should be able to manage this well with our investments. We can use cascade systems in heating. We can ensure that they are integrated to integration. We can also use eco panels. We can use timing programs. We can control fan coils and radiators. We can also use frequency converters. Of course, we need a system to ensure that we do all of them. We'll need to have multiple measurements with field elements which need to communicate data to a dashboard, and which should be interpreted very well by us as engineers. Here, the most important thing is ventilation. Together with the pandemic, we have a higher need for fresh air, but as we give fresh air to space, we actually arrange that according to peak number of people. What we see at universities or conference rooms, that they can operate with 10% of the capacity. And here, asset application management becomes important. There are different asset control strategies. Passive infrared is one of them. Camera screening or scanning is one of them. Even radio frequency and actually Wi-Fi fluctuations can be also used. But CO2 sensors, despite their late reaction or response, give actually better management levels. And now we even decided to put aside CO2 sensors and send the polluted air inside an indoor area due to pandemic reasons. Therefore, in summer, we give cool air, and in winter, we give warm, fresh air. And we have rotative and other systems for heat recovery. There are other devices that have batteries, and they are indispensable part of these new systems. In the field, I see that I see this question of whether every building with HVAC automation is a smart building. Here we need to ask the right question. Have we seen the right system preference for HVAC? Have we looked at alternatives for air, soil? What are the user preferences? This automation of the smart system also need to be determined by an expert. We can find answers to these questions, but we should also give an answer to the question of whether capable people work in building operation. And here we have suspicion. We need to have the capability to analyze SCADA-based data and read these automated systems very well, and we see important shortcomings. So when we conduct a SWOT analysis, our strength is that we know the industrial building sector well. We have also resource diversity like air, soil, water. Also, we have HVAC automation with good engineers. We have good practices there. But when we look at the opportunities with regulation and industry applications, we see threats like dependence on outside working technology and energy dependence. So we have to also improve our weaknesses together with threats. Heat pumps become also important as we target zero energy buildings. They should be supported by renewable energy resources like sun. And at Akdeniz University, we used this pump with solar support. We had monitoring through the SCADA system, through a PLC, and tried to operate it in the most efficient sense. And we saw that the system can increase up to 4 COP and work at an average of 2.93. As we move towards zero energy building, we should look at air, wind related resources and conduct actually feasibility studies accordingly, including for air and soil. So tree generation is another important matter where we have more than one of these resources. Also, we have gas engine. We generate 804 kilowatts of energy and 4,500 kilograms of flue gas is given to this steam system. So it provides steams like at 300 kilowatts per hour. Plus this gas engine has one cooling jacket and another after cooling or turbo element. When we combine it with plated exchangers, we can have combined 500 kilowatts of energy. Here you see a gas engine, waste heat boiler, exchangers. If they fail, a radiator, our analysis shows that it can work with 86% efficiency. A gas engine, 245 kilowatts in this application. So water is sent through the red line, and the flue gas, it was given to absorption chiller, and it provided 1,950 kilowatts of cooling. And with after water, we obtain water with low water, and our analysis shows 87%. With absorption chillers, actually, we can say that they are indispensable as we need actually cooling requirements in 4 seasons. Evaporative cooling is another one, but we see indirect use of it because in direct use, you give humid air. Here, actually, you add secret heat to this perceptible heat. We tried it first in split air conditioner. You cannot have it in an industrial facility, but we had evaporative cooling with such pads. You see that they work simultaneously. And the humidity, when stands at 20%, the consumption fell by almost 20%, and cooling increased by 24%, and COP almost rose by 20%. However, in high humidity scenarios, the increase in cooling capacity was 8%. In COP, it was around 7%. This can be chosen in low heat climates, but not for industrial ones. Here we use chillers. If you have air condensing ones and have evaporative pads behind, these data show that based on our simulation on many chillers, that the cooling capacity changes depending on the outside temperature, along with the COP. With high regression numbers, we saw that in climates like Urfa, the energy consumption increases all the way to 15%. In Ankara, it's 7%. In Antalya, it's around 5.8%. So this is an alternative, actually energy efficient system for an industrial building. Last but not least, the future will not come. The future is here. We're going to talk about nanofluids, not just air or soil. Nanofluids increase the thermal conductivity of the traditional components with particles that have a size of 1 to 100 nanometers. And they increase the fluid conductivity coefficient, and you can have metals or metal oxides, also other elements like graphene. I would like to give two examples quickly. We used it in solar and wood solar systems, with one using fresh water, the other one nanofluids, especially iron-based silicium fluid had an increase of 2.50%. And as you see here, the transfer coefficient in the fluid with iron oxide rose to 1.6. And here you see the black line showing spontaneous data or instant data with the pure water, and the other one shows efficiency curve with the fluid that includes iron in it. And here, when we look at the exchangers, we tried 13 different fluids. Ethylene glycol was put, and titanium oxide was also included. I would like to point your attention to the 13th one. 0.3 silver was actually added as a topping without commercial value, and the thermal or heat production coefficient rose as such. This was a radiator, but at least a heat exchanger. And when we tried it here, this line, ethylene glycol water, was here, and this silver addition took it to a very high total heat transfer coefficient. So many industrial ventilation examples will benefit from nanofluids for heat transfer in many areas. I used my time as efficiently as possible, although with a few minutes delay. Thank you. Thank you very much. It has been a very good presentation. You pointed to important aspects like where you can achieve success with designs, and you also emphasized the shortcomings about the lack of trained personnel. Also, this testing and balancing aspect is another one. There are very good practices and applications, but whether the program systems meet all the conditions or whether the system is actually balanced is not known. I mean, there's not much weight. We don't not see much weight on this area, and I believe that this is important. You choose a frequency controlled pump, but you don't know whether it works within the ranges of the design. And when you don't control it, that means energy actually spending. These are all important points. Thank you for highlighting them. Also, you pointed to pandemic. Ventilation is critical in pandemic, and we refer to fresh air's importance. But we know that increased ventilation also has an impact on our energy efficiency. In addition to boiler systems, can you inform us whether we have energy efficient technologies? Test adjustment and balancing is important for us, and seeing the emergence of engineering areas in the last 5 years is actually very good, and I think they are indispensable for energy efficient buildings. I think we should see a higher number of engineers working in this field and in operation. Actually, the system should work under the supervision of capable engineers. Yes, in the pandemic, fresh air amount increased, and here asset management, recovery, we have discussed all of them, but what can we do there? For example, the heat pump can be added to this system, because in a cross flow exchanger system, we can think of effectivity rate of maximum 70%. So cool air in summer and warm air in winter, we have only a 70% effectiveness between the systems. If we can have heat pump here, I think we can make it more efficient. Of course, everything we do has a first investment cost, but these systems are known to pay back very quickly and provide long-term efficiency. Yes, thank you. Regeneration systems prefer absorption-based cooling system, but there are low COP levels. Is that a problem? Should we pay attention to that? Yes, in comparison with vapor compressed systems, we talk about heat pump and refer to 3-4 COPs. In absorption chillers, we had this discussion. If it has one layer, 0.5, 0.7, in 2 layers, it's 1.3, 1.4 of COP, but the compressed system works directly with electricity. However, a system like regeneration, we used wastewater. You saw the values of the gas engine sending out waste exhaust fume, or we saw 400, 500 kilowatts in water. That's what we call absorption system, a heater, a condenser, and operator, adding up to 4 exchangers in total. When you add that wastewater to condensers, here, when radium bromur is separated from water, COP actually can be low, and it doesn't make a huge difference. But of course, in electricity or in combustible unit, we should not have that value, that situation. Thank you, Professor. Also, you said the future has arrived and nanofluids will enter our lives gradually. You referred to examples from implementations or applications. So can we use nanofluids in the current systems as we know it? What would be the transition costs? And can we say that there are acceptable durations for their payback? How quickly do you think will those fluids enter our lives? We experiment with them in thermal aspects. And nanoparticles sizes are characterized with different surfactants, and we started to try them in thermal systems. Will they be quickly commercialized? Well, we need time, especially in terms of material science. When they are actually static, they collapse. They actually turn into granules. And that's why we have to have surface processing or other treatments, surface treatments, and then produce them in amounts, volumes that can be used in commercial scenarios. Then, of course, we'll see their commercialization. We conduct preliminary studies with 5 liters, 7 liters, 10 liters, but of course we need higher volumes. Even we need to have tribological assessments because this is a metal in this fluid. When I tried in a radiator, I encountered, for example, a hole formation. So we should look at the corrosion or other aspects. But an increase of 2% will lead to important conductivity benefits. In early 2000s, we were talking about absorption-based chillers, and we were curious about low COP, etc. And they are now an indispensable part of 3rd-generation systems. After a while, they're going to be used in many actually systems after completion of these tests. They will be more commercialized. Thank you very much. I want to come back to the pandemic. You are Antalya, head of the Chamber of Mechanical Engineers, and Antalya has actually an intensive number of tourists. Have you been able to observe the touristic facilities in the pandemic? Have they managed this process successfully? What kind of measures have they taken? Have they applied to the Chamber of Mechanical Engineers? What kind of studies have you pursued? Well, the Chamber of Mechanical Engineers created the climatic committee, and even medical physicians were part of it, and we made various publications emphasizing the importance of fresh air. Actually, our chamber has an internal group discussing the importance of fresh air, not only starting with the pandemic, but way before. We have been saying that since 2015, especially for schools, and the pandemic increased awareness of fresh air, and hotels developed their fresh air systems very quickly. They started to use ultraviolet. They increased their grades. Here, the problem is about the technical managers. Some of them come from engineering backgrounds. They showed quick reactions and they achieved results. Of course, they consulted with us. They followed our publications and statements, and we did not see any clear tourism-related issue. But in places like Mediterranean region, recirculation devices caused the biggest issue, and actually putting them out of service is quite difficult, considering that the temperature reaches 40 degrees Celsius. You cannot achieve it with fresh air only, but we try to provide as much fresh air as possible through natural or mechanical means. And actually, we made revisions to the entire building, and we ensured that the mechanical ventilation and natural ventilation were enjoyed in our chamber building of 5,000 square meters. Thank you very much. By the way, this marks the end of our session. We'd like to thank all our participants for their kind presentations. We discussed lightning, electricity appliances, energy efficiency, and tests conducted in industrial zones. These were all beautiful topics. Thank you very much for your kind and valuable insights. I also thank our audience. I wish you an enjoyable evening. Thank you. Thank you. Bye-bye. Evening. Good evening. Thank you.